So I've opened the Quinidine dataset here. You'll see I can probably do some baseline correction for the carbon-13 spectrum. So I'll do a polynomial just to try to flatten it out a bit. That's the best it's going to get. Next I need to align my spectra. It's good to do that and to just zoom in on a couple of contours and check that you're happy with the alignments, and then do the same for the HMBC. You can work off of any spectrum for the peak picking. I like to start from the HSQC. You see the molecular connectivity diagram gets built as you do the peak picking. You see the software's pick this up as a CH or a CH3. If I look at the proton, it's a very large singlet, which is typical of a methoxy group. So I'm going to make this in the merged carbon table. I'm going to make this a CH3 and define the hybridization. I'm going to skip these contours for a moment. Again, it's picking this as a CH or a CH3. these two signals are actually from the same CH2. So the software's picked those up correctly. Now if I zoom in here, see this contour is actually an overlapping of two carbon signals. This one and this one belong together, and this belong together. So I'm going to click this contour first, get my CH2 group, and you see there's a ring or something here starting to take shape. I'll pick this one here. Now I don't want it to attach to the grid line. You see how there's this arrow, so if I hold shift I can make sure that it actually belongs to the bottom carbon. So it creates a separate CH2 group. And now for here, for this overlapping contour, I'm going to pick here, and then I'm just going to adjust the size of the box so I don't have a lot of overlap. And then I'm going to pick down here, and I'm just going to make sure my boxes don't overlap at all. So I've picked everything from the HSQC depth spectrum. You see there's a lot of connectivities, and my molecular formula so far accounted for C16H22. Now I have this signal here. If I want to investigate it further, I believe this is a CH based on the carbon and proton chemical shift. So I'm just going to go and define that here as a CH. So now I'm missing all of my quaternary carbons. So now if I look here, there's 4 quaternaries. So I can pick them. It looks like there's some sort of fused ring system over here. Again, it's not necessary to move things around here like I am, but I do it because it looks like there's possibly a benzene ring here, or a fuse, a couple of benzene rings, based off of all these different correlations that I'm seeing. So now you see my molecular formula C20H23. So at this point I usually double check the HMBC, and I look to see if there's any extra correlations, weaker correlations that have been picked up that maybe shouldn't have been, or any ones that the software may have missed from the synchronized peak picking. Generally, it's a good idea to under peak pick rather than over. So these correlations here are pretty weak. I'm going to actually unselect those correlations. Overall, I think the software's done a pretty good job. Then check the cozy to see if there's any other major correlations. I think the software's done a pretty decent job. You can always pick and unpick if you're not sure. If you want to see what it does to the molecular connectivity diagram. I'm going to keep this as is. So now I'm going to add in the known molecular formula. You usually get this from high resolution MS. Now we know I likely have a methoxy group, so I'm going to leave that over here. And based on my proton spectrum, we know there's an exchangeable OH most likely there. So I've got an OH group here that's likely connected to one of these, possibly this CH here, based on the chemical shift. And I've got a couple of nitrogens that I don't really have any information about because I don't have a nitrogen HMBC or any nitrogen spectra, so I'll just leave them kind of floating. So next you want to perform a molecular connectivity diagram check. Now you get this warning saying that there's a range that are not specified, and I'll explain that in a moment, but I'll do a quick check. You see it pass all tests, and then it's telling me the number of protons from here exceeds the number of molecular formula, but that's okay. My molecular connectivity diagram is correct, so that's all that really matters. Now if I go to my merged carbon table, it gave us a warning because the number of atoms weren't defined for all of these. So I'm just going to, all the ones that are not defined as 1, I'm going to define them as 1. And then I can look at the hybridization and what I suspect of these. You see some of them are not hybridized at all, or they're not defined. So any of the ones in black. Now, based again on the chemical shifts of these and the different groups, I'm suspecting and I can suggest that these are likely sp2 hybridized. It's likely an aromatic. So the more information you put in at the beginning, the greater chance of there being some success and the less time it's going to take. Now you see here the software has defined this as not SP. I'm going to change it to SP2. And then this guy here at 59, I'm going to change to sp3 hybridized. Then I'm going to change this one to an sp3. Again, I'll do a quick check. You see that warning's gone away. So I can go and click generate. But again, I'm going to just define a couple of things that I'm certain of. So if I force a couple of bonds, so I know this is a methoxy group, so why not draw it in? I know I've got an OH group. I'm going to draw that in. So those are the two bonds that I'm going to draw. Now I could draw more in to force things, but I want it to be as unbiased as possible. And so now it's just going to take some time to go through and generate structures. So I'm going to click generate. I'm going to unselect enumerate all possible valencies for nitrogens. And I'm going to click OK. Now it's going to run through all of these possible structures. I'll probably speed up the video at this point because it's going to take a little bit of time due to these nitrogens that are not constrained by anything. So yeah, we'll see some results when they're generated. So the software is finished generating structures. You see the results. 7 molecules have been stored out of all of them that were generated, these 723 that pass the filters. There are no extensions for connectivities, which is always a great sign. So I'm going to hit OK. So you can scroll through to look at all the different molecules that were generated, and you see the software has done a verification based on our predictors in the background. I could also go and click on this view to get the structure list. And then if I want to do a sort, I can click sort, and you can search for the best structure automatically, or you can pick your particular match factors or use a combination. I will do that. And the software has generated the best structure, which is in fact quinidine, which is what this data set was showing. And you see it's got the lowest deviation score for the experimental to the chemical shifts in the predictor database. So this has been the de novo structure elucidation of quinidine using ACD Lab Structure Elucidator.